question you are having. Amino question. So this is pyramine salicylic acid. So in this synthesis, you are asked with a 5-mark question, like there are 2 questions. One is write about the lipophilic parameters. For example, you are asked to write about lipophilic parameters. So you need to explain about 5-6 hydrophobic parameters and lipophilic parameters and their equations. Instead, you are having next question as synthesis of para-aminosalicylic acid and INH. So this is a common question repeatedly asked. So this is isonicotinonic acid hydrazide. So isonicotinonic acid hydrazide. There are 2 questions. So you know, like out of 9 you have to choose 7. So you have an oscillation which question to select. You select this question. Like mathematics you will get 5 out of 5. So any student who is giving the points correctly for para-aminosalicylic acid, so there is phenol on nitration. So the first step is phenol on nitration. You will get nitrophenol. So in this nitrophenol, if you do a metabolic reduction, so in this metabolic reduction, you will get aminophenol. So what is the next fragment needed is this function group, carboxylic acid group. So anywhere if you want to add carboxylic acid group, you can remember Cole's reaction. Addition of carbon dioxide at 100 degrees. So you will get the addition reaction here. So you are having the addition in this question and remaining all other things same. So how to remember? Phenol, nitration. So you get this is electrophilic substitution reaction. Most preference goes to para-motion. So para-nitrophenol, and then you have a reduction. In this you are getting aminophenol and addition reaction. Addition of carbon dioxide through Cole's reaction. So this is the first synthesis in case of antitubercular agents. So what I mean to say here is, one important note in medicinal chemistry 3 is, first thing you concentrate in antibiotic repeated question, and next thing you concentrate in small molecules. You want to study 17 synthesis, you take first synthesis you take as para-aminosalicylic acid. Next you take it as INH. So what you will build in confidence that these are the easiest parts. So one is phenol, nitrophenol, aminophenol, addition of carbon dioxide. So this is synthesis of this antitubercular agent, synthetic agent PAS, para-aminosalicylic acid. So next we can see about the synthesis of isonicotinic acid hydrazide. So isonicotinic acid means there is a pyridine ring and there is a hydrazide linkage and then there is a carbonyl group, C double bond O group. So how to get this INH? So the mechanism is this isonicotinic acid mimics the mycolic acid, and this mycolic acid is present in the bacterial cell wall. I will repeat, that is, this is the important question. Give the synthesis of INH and write its mechanism of action. So the mechanism of action is mycolic acid is the important constituent of the bacterial cell wall. So mycolic acid will be inhibited. It mimics the mycolic acid. So mycolic acid in synthesis will be inhibited. So the cell wall will be interrupted. So interruption of the bacteria is called as mechanism. Okay, so now we will see about the synthesis. So how to study the synthesis? So here we are taking, what is this? Pyridine carboxylic acid isomerizes. It gives So gamma picoline. So this is gamma picoline. Sorry, this is isonicotinic acid. This is alpha beta gamma picoline. This gamma picoline oxidation. This is Kuhn-Ruth method of oxidation, where the C-methyl group get converted into C-carboxylic acid. So this is carboxylic acid. So now what we need is an addition with hydrazine. So this is nucleophilic addition of carbonyl compound with nitrogen type of ammonia type of compounds. So I repeat. This is gamma picoline oxidation reaction with hydrazine. You will get isonicotinic acid hydroside. C double bond O NH NH2. So we have studied two synthesis. One is para-ammonium-salicylic acid, other one is 9H. So now another 15 syntheses are there. So you can concentrate. Maybe you will get some 15 marks. Thank you.